Good day. In this video, we will learn about the blood groups found in the bodies of living beings, their characteristics, strengths, and weaknesses. Don't forget to subscribe to the channel, like, and comment. You can select language settings by clicking the gear icon on the edge of the video screen. Enjoy watching. First of all, blood is a vital fluid that circulates within the vascular system of living beings, composed of fluid plasma cells, namely red blood cells, white blood cells, and platelets. A, B, O blood group system. This is a classification method based on the presence or absence of A and B antigens in red blood cells, and is based on hereditary characteristics. According to this classification, individuals' blood can belong to the A, B, O, or AB group. Antigens from other blood groups may also be present within these blood groups. There are a total of 8 blood types, named A, B, AB, and O, each containing positive and negative forms. These are positive, A negative, B positive, B negative, AB positive, AB negative, O positive, and O negative. Blood groups have emerged over millions of years through genetic mutation and natural selection. O blood type, the oldest, developed millions of years ago when humans had not yet fully evolved and diverged from other related species. Therefore, O blood type has a strong immune system. O blood type is quite common worldwide and is thought to have evolved in regions where severe forms of malaria were prevalent. A blood type emerged in early human groups, generally as a response to changes in dietary habits and resistance to ancient infectious diseases like smallpox. Blood type A is concentrated in the European geographical region. B blood type is thought to have emerged and evolved 3.5 to 15 million years ago. B blood type is most concentrated in Asia. AB blood type is the newest and rarest blood group, formed by the combination of A and B type genes. It likely arose from the intermingling of B blood Asian populations in the Near East, Caucasus, and Anatolia regions with A blood European populations. Blood group determination occurs when, in the A, B, O system, the agglutination, clumping, of red blood cells results from the encounter of appropriate antibodies with antigens. The first person to classify blood groups was Dr. Karl Landsteiner, an Austrian-born immunologist and pathologist. By discovering the differences in the structure of human blood, he revealed the dangers of incompatible blood transfusions. In 1901, he demonstrated that humans have at least 3 blood groups, based on the type of antigens attached to the outer layer of the cell membrane in red blood cells. Landsteiner named the blood groups A, B, and C. The following year, his students Alfred de Castello and Adriano Sterli, through intensive studies involving 155 individuals, defined the blood group system as A, B, AB, and O. Dr. Karl Landsteiner was awarded the Nobel Prize in Physiology in 1930 for his work on blood grouping. A year later, AB blood, which carries both A and B antigens but lacks AB antibodies, was discovered. For these studies, Dr. Karl Landsteiner was honored as the father of transfusion medicine. The first blood bank was established in 1937 by Bernard Fantus at Cook County Hospital in Chicago, United States. The term blood bank was first used there. The gene that determines human A, B, and O blood types is located on chromosome 9, specifically at 9q34.1, and is called A, B, O glycosyltransferase. Blood types A and B are dominant, while blood type O is recessive. It is impossible for a child with blood type O to be born to parents with blood types A or B. Red blood cells, or erythrocytes, are the most abundant cells in the blood and are produced in the bone marrow. Their main function is to transport iron protein in blood cells, along with hemoglobin, to body tissues with oxygen from the lungs and to return carbon dioxide produced in the tissues to the lungs. The lifespan of red blood cells is approximately 120 days. Low red blood cell count can cause anemia, B12 deficiency, weakness, dizziness, and shortness of breath. A test called red blood cell (RBC) measures the level of red blood cells in the blood. An antigen is a substance that can stimulate the production of its corresponding antibody under certain conditions. An antibody is a substance that can only react with specific antigens. Blood group antigens are carried on the surface of red blood cells. If someone with blood type A receives blood type B, the red blood cells in the donor's blood will be destroyed by antibodies in the recipient's serum. Similarly, the red blood cells of blood type A will be broken down by anti-A antibodies in blood type B. In this situation, the blood transfusion will fail. Transmitting the correct blood type is crucial. Relationships between blood groups. O blood group does not contain antigens belonging to blood groups A and B. Its plasma contains both A and B antibodies. It is the oldest blood group evolutionarily and elicits the most aggressive immune response. In some countries, the letter 0 for O blood group can be confusing. It is thought that O blood originates from the German word one, meaning without. In English, O is pronounced as 0. O blood group 0 means the absence of the antigen. O negative blood can only accept ORH negative blood. ORH negative blood can donate blood to all blood groups. As a universal donor, it is the safest blood group in emergency situations. ORH positive blood only accepts O negative and O positive blood. ORH positive blood donates blood to all positive blood groups. ARH positive blood can only receive blood from a positive, a negative, O positive, and O negative blood types. ARH positive blood can donate blood to a positive and AB positive blood types. ARH negative blood can only receive blood from a negative and O negative blood types. ARH negative blood can donate blood to a positive and a negative, and AB positive and AB negative blood types. A blood type cells contain the A antigen, while its plasma contains B antibodies. BRH positive blood can receive blood from B positive and B negative blood, and O positive and O negative blood types. BRH positive blood can only donate blood to B positive and AB positive blood types. BRH negative blood can only receive blood from B negative and O negative blood types. BRH negative blood can donate blood to AB negative and AB positive blood, and B positive and B negative blood types. B blood type cells contain the B antigen. Its plasma contains A antibodies. ABRH positive blood accepts blood from all universal blood groups. AB positive blood is a universal blood recipient. AB positive blood can only donate blood to its own group, AB positive. ABRH negative blood accepts blood from all negative groups. AB negative blood can donate blood to its own group, AB negative and AB positive. AB blood group cells contain both A and B antigens. However, its plasma contains no antibodies from groups A and B. Distribution of blood types according to geography. It is believed that blood types originated in the three main races of humans: A in Europe, B in Asia, and finally O in South America and Africa. The migration and intermingling of these races led to the current distribution of blood types. Isolated human populations with completely different blood types exist on every continent. For example, blood type O is relatively more prevalent among Siberian inhabitants. O blood is also very common in some parts of Switzerland. The most common blood type on Earth is O. O blood reaches a 100% prevalence in Native Americans of South and Central America and in the southern two-thirds of the United States. ORH-positive blood is at high levels in the overwhelming majority of Native American tribes. Purebred Native Americans are 100% ORH-positive. The few existing ORH-negative, A, and B-negative blood types are known to have resulted from racial mixing between Europeans and indigenous peoples. In Australian Aboriginal people, the level of O-positive blood is around 75%. The second most common blood type is A. O and A are the original blood types of the Aboriginal people. Blood type B and negative blood types were brought to Australia by immigrant foreign populations. Purebred Aboriginal people do not have the Rh-negative factor in their blood. This genetic structure comes from the fact that Aboriginal people lived in isolation from other human populations on the Australian continent for thousands of years. Golden blood, or Rh-null, the rarest blood type in the world, was first identified in an Aboriginal woman in 1961. Golden blood has no Rh antigen in its red blood cells. According to estimates, there are approximately 50 people in the world who carry golden blood. The blood type of the white population living in Europe consists predominantly of blood groups A and O. Rh-negative blood occurs at a higher rate on the European continent compared to other geographical regions. It is followed by O-group blood. Rh-positive blood is also found on the continent. B-group blood stands at 10% in Europe. AB-group blood is rarely seen in Europe. In Africa, ORH-positive blood is more prevalent. Blood type B is present in smaller amounts. The Duffy-negative, FY-A, B phenotype, which prevents the malaria virus from entering blood cells, is very common in people of African descent. 95% of Black Africans have the DRH1 antigen. For reasons unknown, African people have been observed to have lower white blood cell, leukocyte, and neutrophil counts compared to other human groups. Blood type B is very common in Asia, especially in North India, while it is rare in Europe and Africa. It is virtually non-existent among Native Americans and most Australian Aboriginal groups. Blood type AB is most common in East Asia. In Korea and Japan, 10% of the population has AB blood. In China, the rate is 9%. In the Caucasus region, also known as West Asia, particularly in Azerbaijan, AB blood type is found at a level of 9%. Globally, AB Rh-negative is known as the least common blood type. The proportion of AB Rh-negative in the population is 1%. The A1 antigen is a subtype of blood type A and is used in the classification of blood type A itself. Approximately 80% of individuals with blood type A belong to the A1 subtype. The remaining 20% belong to the A2 subtype. The characteristics of A1 and A2 blood types are as follows. A1 blood carries more and stronger A antigens than A2 blood. Antigens of A2 blood type develop antibodies against A1 blood type in 1% to 8% of cases. The rate of antibody development against A1 blood type can reach up to 25% for AB2 blood group antigens. If these conditions are detected, the patient cannot receive A1 blood type. Instead, O-negative blood is preferred for A2 blood type. It is seen to completely replace A2 type among Australian Aborigines and Eskimos, in certain regions of Indonesia, Pacific Islands, India, Canada, and northern USA. A1 type is most commonly found among Blackfoot Native Americans and tribes around Alberta and Montana. Given the surprising high concentration of this blood type in a continent where O blood type predominates, researchers have interpreted it as evidence of waves of migration from Asia to the Americans. While A2 blood type is found in up to 50% of the Sami people living in the region called Lapland in Scandinavia, it is rare elsewhere. In blood type B, unlike in blood type A, there is no subtype distinction between B1 and B2 antigens. The white blood cell known as B1 is a special type that produces antibodies to protect the body against microbes. It should not be confused with the antigen. Blood groups, immunity levels, and diseases. Blood group A, stomach cancer and cardiovascular diseases are 20% more common in individuals with blood group A compared to blood groups O and B. Fatal anemia, also known as pernicious anemia, and possibly childhood pneumonia are also diseases associated with blood group A. Because digestive system disorders may occur, individuals with blood group A should prioritize consuming vegetables and greens. Individuals with blood group A have a stronger ability to cope with stress compared to other blood groups. They are a group that adapts easily to environmental changes. They have a predisposition to vegetarian diets. Antibody diversity is lower than in blood group O and may be insufficient in some cases. O blood type, thanks to the high levels of anti-A and anti-B antibodies in its plasma, it provides a very rapid and strong first defense response against foreign microorganisms and viruses. It is linked to a 40% higher incidence of duodenal ulcers, especially in individuals who do not secrete water-soluble antigens. Stomach ulcers are also more common in O blood type individuals. O blood type has a natural protection system against severe forms of malaria. The risk of dying from malaria is lower than in other blood types. They are resistant to environmental factors such as air pollution. It has a low blood clotting rate. This reduces the risk of vascular blockage and heart attack. However, bleeding may take longer to stop. An immune system that is hyperactive and constantly on alert increases the risk of type O blood attacking its own tissues. Consequently, individuals with this blood type have a high predisposition to autoimmune and allergic reactions, such as asthma, hay fever, thyroid disorders, Hashimoto's, and joint inflammation, arthritis. Blood type O has high stomach acid, which allows it to digest proteins very easily. Therefore, they are biologically well suited to diets heavily focused on animal protein, i.e. hunter-gatherer diets. Blood type B, susceptible to urinary tract infections, bacterial and inflammatory infections, may have a predisposition to pancreatic cancer. Blood type B may increase the risk of developing type 2 diabetes. In addition to blood clotting problems, there is a higher risk of cardiovascular disease due to high cholesterol levels. Blood type B individuals have a high level of immunity. They have a body system resistant to serious illnesses. People with blood type B are less exposed to tick bites. The rate of kidney stone formation is low. Because the B antigens on the cell surface resemble some viral structures, the immune system may sometimes be slow to recognize slow-growing, insidious viruses such as influenza, pneumonia, and some chronic viruses as foreign. Blood type B has a strong immune system, but one that can become unbalanced and prone to attacking its own tissues. Therefore, they are more susceptible to autoimmune disorders such as lupus, systemic lupus erythematosus, multiple sclerosis, MS, and chronic fatigue syndrome. People with blood type B tend to produce higher levels of the hormone cortisol in stressful situations. This can make it more difficult to maintain balance in stress management. Individuals with blood type B have a versatile and resilient digestive system that can easily tolerate both animal and plant-based foods, including meat, dairy products, and vegetables. In the AB blood system, clotting disorders, cardiovascular diseases, and cognitive impairments related to dementia may occur. AB blood plasma does not contain naturally occurring anti-A and anti-B antibodies. This can cause the immune system to be slower or blind to detecting some foreign pathogens and harmful cells, especially structures that resemble A or B antigens. Due to a lower diversity of naturally occurring antibodies, individuals with AB blood type may have lower resistance to E. coli, salmonella, staphylococcal infections, and serious urinary tract infections. AB blood type individuals have a lower ability to detect and destroy cancerous cells that resemble A or B antigens, particularly in stomach and pancreatic cancers, at an early stage. People with blood type AB generally have low stomach acid. They have difficulty digesting meat. However, their ability to tolerate animal proteins is balanced. It is important to remember that blood type alone cannot be a cause of disease. Genetic factors, environmental influences, and lifestyle also play a role in these diseases. In cases of incompatible blood types, A, B, O, especially when the mother has blood type O and the father has blood type A or B, jaundice may occur in the newborn. The most severe blood incompatibility risk arises from the incompatibility between Rh-positive and Rh-negative blood types. This is a serious problem. It causes the destruction of red blood cells in the baby, resulting in anemia at birth. Generally, there is no risk of blood incompatibility in first births. The mother's blood begins to produce antibodies after the baby is born. The risk is high in second births. The mother now has memory cells. In a second baby with Rh-positive blood, the mother's Rh-negative antibodies cross the placenta and attack the baby. This is called erythroblastosis fetalis. As a result, the baby may develop serious life-threatening conditions and diseases such as anemia, severe jaundice, heart failure, and brain damage. Rh incompatibility at birth can be largely prevented with a vaccine and injection called anti-D immunoglobulin. This injection prevents the mother's negative blood antibodies from forming an antibody defense system against the baby's positive blood red blood cells. This injection is given to the mother at 28 weeks of pregnancy or immediately after birth. This injection neutralizes the baby's blood cells before the mother's system recognizes them and produces antibodies. In other words, the mother's immune system is not activated. Immunoglobulin was first introduced to the market in 1967. A, B, and O antigens develop long before birth and remain permanent throughout life. Antibodies A, B, and O are passively acquired from the mother, but the child begins to produce its own antibodies when it is 3 months old. Thank you for taking the time to watch. I hope this was a successful educational video. You can support us by liking it. Share your thoughts in the comments section. Goodbye.